In the next problem, we're asked to find the potential energy for a capacitor before the slab. The slab, by the way, is known as a dielectric. So let's call this the potential energy initially, which we know is Q squared over 2C. And if we use the fact that Q is C times V, then we can get another equation for the the potential energy, which is basically that the potential energy is 1/2 the capacitance times the voltage squared. And we use this because we're given the voltage across. So in this case, the initial potential energy, or pre-slab potential energy, is 1/2 times 13.5 pico, which is -12 farads, times a voltage of 12.5 volts, quantity squared, and that gives us a potential energy of 1.055 times 10 to the minus 9th joules, which is the same as 1055 picojoules. Since they started with pico, we might want to use pico in the next as our answer. And now they say, what is the potential energy afterwards? So now we have final potential energy. We know that that's putting the slab in. Let's call this initial, call this final charge squared over 2C final. And then we put all the initials on part 1. And now we know that the slab, when you put that into a capacitor, its value is given by the constant kappa, dielectric constant, times the old capacitance, so it increases the capacitance. And now if we look at this, it doesn't affect the charge at all, because the charge is affected by the voltage. So this is the same as Q initial squared over 2C initial times kappa. And if we look at this value, that's the same as U initial over kappa, which means that we have 1055 picojoules divided by 6.5. That gives us 162 picojoules. And notice that there's a difference, obviously, between these two. So that difference is going to be the work in or the change in potential energy we know as work from earlier semesters, chapter 8 or 6 or 7, I believe. And that's going to be 1055 picojoules minus 162 picojoules, or 893 picojoules, which is used in inserting and moving the slab in there and moving the current within the slab to charge.